Hello everyone, welcome back to the DevOps course from McCad Guild. In this session we are going to discuss the fourth module of DevOps training. If you have missed the previous sessions, please check the links in the description. This module deals with continuous integration. To take a brief look at the topics to be covered in the DevOps course Module 4, let us see what are the tools used and also understand the role of disintegration in DevOps. Going back to the introductory module, we discussed the necessity of DevOps and also understood that the motive for the necessity of DevOps originated from Agile. Since the industry is moving from traditional software development lifecycle or the waterfall development model towards the Agile model, it's the ideal time for the industry to embrace automation and employ it across all sectors that can be automated and achieve quicker deliveries. Let's have a sophisticated overview of this topic by considering a project that runs for 12 months. The project now is segmented into 4 sprints. The time span allotted for each sprint is 3 months. Sprint is nothing but a shorter duration of time. These sprints can be effectively utilized in development activities towards delivering a useful product for customers' evaluation at the end of each sprint. Each sprint of 3 months has a set of activities to be accomplished. However, the topic on priority is development. Development will be succeeded by documentation and various kinds of testing. These are the varieties of testing: unit test, regression test, performance test, system test, and basic acceptance test as well. There are multiple tasks has to be completed in the span of 3 months, which includes code reviews or code checks that are to be completed to conduct releases at the end of each sprint. Releases can be of various types. It can be a kind of deployment which involves product deployment at staging on the production server, or release can be a delivery. That means the product is ready for deployment. Once the customer provides the consent, the product would be delivered. As there are multiple tasks to be accomplished within the allotted time span, the most vital and critical tasks must not be neglected. They are development and testing. These activities demand considerable effort. To make sure that release happens at the end of the sprint, automation must be employed in all adaptable sectors. Another aspect of prime importance is that if the developer is conducting fatal errors unknowingly during coding, which results in infusing bugs, as testers, you should identify that bug as soon as possible and inform the developer so that the bug is fixed immediately. Why is this awareness important? Let me consider a scenario where there are 3 developers, A, B, and C. If A makes a change in the project and unknowingly he introduces a bug and A is unaware of the bug introduced, since these projects are collaborative and multiple developers are involved, as per the practice, the succeeding developer would pick up the latest work completed by the previous one. In this case, if B is the succeeding, he will take the latest work done by A and he will perform his tests performed on A's changes. Now, if A introduces a bug and B also modifies his module to support A module, then later if A figures out that there is a bug in his module, then to make change in his module, he has to communicate the same to B as well, because the B module is dependent on A's module, so B has to modify his code as well. If there are further dependency, then anyone has to align their code for the bug fix change, which is an expensive exercise. Hence, it is always a healthy practice to identify bugs at early stages. Thus, to identify bugs at early stages, continuous integration is employed. What is continuous integration? Continuous integration is a method to split software development efforts into smaller segments and apply them often. To exemplify, test your project often in traditional development methodology at time intervals of 2 weeks or 3 weeks when you get a release from the developer. However, in CI, the project is tested and compiled only when there are changes. Therefore, continuous integration is envisioned as a continuous integration pipeline. There are certain tasks that have to be executed in accordance with the fluctuations in the project. For example, let's consider 3 developers, A, B, and C. They are cordially working towards a single project. So, in this scenario, let's say everybody is pushing their code towards Git, version control system. All the developers considered are pushing and pulling the code from this repository. Whenever changes are submitted to Git repository, a system has to be introduced to test and verify the newly infused change. So as soon as the change is made on version control system, the CI system should identify that change and validating it. Thus, the primary task is to compile. Upon successful compilation, the change has to be verified. The verification process can be as basic as a unit test or can be as extensive as running a regression test. The verification process generates matrices like code coverage, static code analysis, and there is a necessity of documentation and the product is packaged. Thus, right after the change is made in the Git repository and during the compilation, there should be a system to notify the corresponding developer that the change has failed to build and the change has to be reworked and to find out the mistake committed. This has to be done at every stage, and this is called continuous integration. Whenever a code has to integrate, it's mandatory to conduct all the above-mentioned checks so as to avoid any uninvited problems in the future. Thus, to achieve continuous integration, 5 textbook requirements are expected from the development team to set up the continuous integration server. The first requirement is automated build. Here, the development team should devise a path to build their product automatically. Thus, upon the command line, compilation should be achieved and binary outcome has to be produced without manual intervention. The second requirement is to have automated tests so that the testing, despite being a unit or regression test or performance test or any kind of test, all of them has to be automated. There were days when they were a dedicated team doing these verifications on the products, and that should not be the case anymore. There would be development effort only on writing test cases and writing executable test use cases, which can be used to actually run automated tests. The third requirement is to have a version control system. The team should use at least one version control system, be it Git, Paphos, Version, ClearCase. It may be any tool that is there on the market right now. The version control system is mandatory because it tracks the changes and identifies who, when, and why a particular change has been made. It allows to track the history of the project and distinguish each change from others, so each change is a separate entity. The fourth part of this session of continuous integration would be about Jenkins. It's not compulsory to employ Jenkins. One can use Jenkins, Bamboo, Houston, GitLab, or any other tools to perform all CI-related activities. The fifth requirement is not a technical requirement, however, is a process requirement. It is called the Fix All Broken Builds. That means whenever a CI build fails, fixing that build should be the topmost priority. All the other developmental activities should be halted and the build failed issue has to be debugged or solved. Above mentioned are the 5 textbook requirements that helps CI pipeline to remain in the green zone. Now let's concentrate on CI server in Module 4. As we have already discussed version control system in the last module, which was Git, and as a development professional, one already be aware of an automated build. One can use automated systems like Maven or Make or Ant and other types of the build system to build projects for automated tests. Tools like JUnit or CUnit or NUnit can be used. There are distinctive tools like Selenium and a lot others can be used for web testing. However, this session would not talk about that topic. The topic of discussion is Jenkins. Let's stick to the topic. What is Jenkins? Jenkins is an open source continuous integration tool which is developed by a company called CloudBees. They also have an enterprise version or a paid version of Jenkins which provides enhanced functionalities. However, open source version of Jenkins would be sufficient for economic development teams. There is no evident change amidst the enterprise version and the free version. The script of is Java and it supports all platforms. That means one can install Jenkins on Linux machine or on the Windows machine or on any OpenBSD or Mac or any Unix machine which can run on Java can run Jenkins. Jenkins supports plugins and slaves. Thus, Windows, Linux, or any other platform can be connected to Jenkins as slave and can have distributed build environment. In our complete course about DevOps, we discuss how to install, configure, administer Jenkins, build tools, create the project, manage plugins, manage security, and also discuss the different types of slave configuration and its integration. We shall also discuss the integration of Jenkins with different version control system. We will also try to see if we can use Jenkins for direct deployments and delivery as well. Right, so in the course this thing will be covered. Thank you for watching this video. Stay tuned for the next module and don't forget to subscribe our channel for more information on all our courses. Get a new dimension to your career by choosing a CAD guild.